Hey everyone, today we're going to finish up rational functions and we're going to talk about graphing them. Now rational functions are tough to graph because they have asymptotes in them, so we need to figure out where those asymptotes are without a calculator. The domain. The domain is everything except for what it's not. I know that sounds dumb, but it's everything except whatever makes the bottom zero. The restrictions, those are also called discontinuities. It's everything that makes the bottom zero. Restrictions are either holes or vertical asymptotes. If the factor cancels, it's a hole. If it doesn't, it's a vertical asymptote. X-intercept and Y-intercept. X-intercept is what makes the top zero but not the bottom. Y-intercept is what you get if you plug in 0 for X. Horizontal asymptotes come in three possibilities. And we're going to look at the degree on top and the degree on bottom. If the degree on top is bigger than the one on bottom, then there's no horizontal asymptote. If the degree on bottom is if the degree on top is smaller than on bottom, then the horizontal asymptote is y equals 0. If they're the same degree, then it's the ratio of the coefficients. So we can talk about all this, but let's actually try a couple problems. Before I get into this, I have to factor. Have to. So what's the top going to factor as? X plus 6 and x minus 3. What's the bottom going to factor as? X plus 8 and x plus 4. So the domain. The domain is all real numbers except what it's not. What two numbers would make the bottom 0? -4 and -8. What are my discontinuities then? They're -4 and -8. X-intercept is anything that makes the top 0 but not the bottom. So -6 makes the top 0 and 3 makes the top 0. So I can come over here at -6, put a dot, and 3, put a dot. Y-intercept. Y-intercept is what happens if you plug in 0. So I get -18 over 32. That's 9 over 16. So -9 over 16. That's a little bit between 0 and -1. Horizontal asymptotes. Okay. Same over same. X squared over x squared. So I look at the numbers in front. What numbers are in front? 1 and 1. 1 divided by 1 is 1. So I'm going to put in a horizontal asymptote here. Okay? Where are the vertical asymptotes? Well, the vertical asymptotes are what makes the bottom 0, but not the top. -8 makes the bottom 0, and -4 makes the bottom 0, but not the top. So at -8 and at -4. Where are the holes? Well, holes are what cancels out. Nothing canceled out. So there are no holes. So I know my graph is going to look like this. It's going to come along right like this, along that asymptote, go through those 2 points and go down. But I need a calculator to kind of help me see the rest of it. So let's graph it, just get an idea what this thing looks like. X squared plus 3x minus 18 divided by x squared plus 12x plus 32. Let's get my normal graph. So it goes up, up, and up. So my graph looks like this. It goes along this asymptote. Now it comes along this asymptote through that point and up along that asymptote and then along that asymptote. So that's how to graph this rational. Let's try one more. Let's factor everything. The top I can pull out a 2. That leaves me an x squared plus 8x plus 15. And on bottom I can pull out an x. That leaves me an x squared minus 25. So on top I've got a 2, an x plus 5, and an x plus 3. And on bottom I've got an x plus 5, and an x minus 5. So discontinuities, anything that makes the bottom 0. it's all real numbers, x cannot equal 0, 5, or negative 5. So my discontinuities are 0, 5, and negative 5. X-intercepts are what makes the top 0 but not the bottom. Negative 3 will make the top 0. Negative 5 would make the top and the bottom 0. The y-intercept, if you plug in 0, but if you plug in 0, you get 30 over 0, so there is none. 30 over 0 doesn't exist. Horizontal asymptote. Small over big was y equals 0, so I'm going to put in the y equals 0. I'm also going to put the x-intercept at negative 3. Vertical asymptotes. It's anything that makes the bottom 0 but not the top. So 0 and 5. So 0 and 5. Holes. Anything that makes the top and the bottom 0. Negative 5. So let's graph this thing and get some idea of what it looks like. So 2x, let me put parentheses here, 2x squared plus 16x plus 30 divided by x to the third minus 25x. Graph it. So it goes down, up, and down. But we know it's got to go through that point. So it's going to go down, through the point, and then back up along the asymptote. And then it goes up like that. And then it goes down on the other side. But you're missing one thing. Remember, this thing has a hole at negative 5. So I got to go to negative 5. 1, 2, 3, 4, 5. And I've got to draw in an empty hole. We'll practice this a lot in class, so don't panic. This is just to give you an overview of what's going on. As always, if you have any questions, come talk to me, guys. Thank you very much.